So welcome. So we're going to be doing a pretty interesting build this time around, and to be honest, this might be one of my bigger builds that I'll do for a while, and I'm kind of excited because it is actually my first really big scratch build, meaning for those unfamiliar, that would mean that this is a design that is mostly of my own and something that I designed on OpenRocket and RockSim to figure out whether or not it would really work super well. And yes, it's more of a common design among small model rockets, but the design intrigues me and I wanted to make a big version of it. And if we're gonna do that, big version, big heavy rocket, this is gonna, by the time it's done, be in excess of 9 pounds, which is why I'm gonna show you some of the heavier hardware that I have prepared to make this thing. It's all gonna be out of hard cast fiberglass and steel and a couple other items. So I'm excited to bring you guys along. This is gonna be a 54mm rocket. Eventually the aim might be for this to be part of the level 2 certification process for myself, but why don't I just go along and show you what we've got. So we've got a little bit of a spread here, and I'm gonna go ahead and show you everything that we have so far before we start building anything. So, namely, here I'll show you that these are all of our fiberglass cast parts. Now this piece right here, you'll notice that I just couldn't help myself, and none of this is actually epoxied in yet, but this was me measuring out exactly where I want my centering rings on my motor mount tube and how I want to actually secure the Kevlar line for this part of the rocket. But anyway, before I get ahead of myself there, let me walk you a little bit through. So these are fiberglass rocket parts from Wildman Rocketry, and Tim over there and company did a great job helping me with some of the initial cuts, but when I got it here, I had to do quite a bit of cutting on my own, which, all thanks to this Dremel tool down here, made it a fair bit easier. But of course, wear your proper PPE. You want a good, steady, or sturdy mask for that sort of thing. You don't want to breathe in any of that fiber. And certainly some glasses and some anchor points to keep that stuff locked down while you're doing it. But anyway, so what all do we have here? Well, we are going to be building, you wonder, where are the fins? Well, these are actually our fins. We're going to be building a tube fin rocket. And this is what it will eventually look like. These are just all the parts stacked up in advance. That is essentially 55.5 or 56 inches high, and it's going to be a 54mm motor, meaning that it's going to have some decent power behind it when we get it loaded. So what all do we have? We have our electronics bay here from Lock Precision. I had to do some additional drilling to make sure that the holes actually are going to match what I'm doing. When you do this, you got to go to your local hardware store and also I got some 1024 threaded rod, and you measure it out to exactly what you want, and sometimes they'll be nice enough to round some of it for you. These are my AV bay lids. You'll see I've already done a lot of the prep work with cutting and drilling and sanding of fiberglass already, because turns out that kind of content isn't exactly very exciting for a video. However, when doing epoxy work with this kind of fiberglass, surface prep is really essential. So what I've learned from some others and what tends to work is I did a water bath, which can be 15 to 45 minutes depending. And then on top of that, I also did some sanding with 80 grit sandpaper, and then I did a wipe over with acetone for about 10 seconds, and then followed that up with isopropyl alcohol. That is a bit of just not mechanical scratching to get the surface to be better to bond with, but also chemical cleaning. But these are our AV bay lids. This is our actual AV bay. It's about 8 inches long. These lids are going to go on either side. These threaded rods go through these holes on the outside. And I have a ton of bolts and nuts to assist in that lockdown process. And that'll be in a later video. And then these middle holes are for the forged eye bolts that are going to be connecting our shock cords and whatnot. So this is to cut this down, this is going to be my switch band that goes in the middle, okay? Our AV bay. This here is our motor mount tube. I designed it to be 14 inches long, that way leaving some extra space for other things. This is the bottom end where we're going to have our AeroPack motor retainer put on. And then we've got a middle centering ring, which I'll epoxy. This is mostly going to be to secure this in here. I'm going to epoxy up this as well and around, of course, lots of fillets to secure things. And this is our top end with about a 1/2 inch clearance there. And I just tuck that down in there for now so it doesn't get any extra epoxy on it or nothing. All right, now you'll see that this is actually our first body tube. This is going to be where the motor mount eventually inserts up into, okay? And up on that part up top is gonna be where then we insert our E-bay. The switch band's gonna be there, and then the top part of our motor tube right here is gonna go on top of that, okay? Now, here we have all of our tube fins. These are largely flush with each other with the exception of that one. It's just a smidge off, but I can fix that. And these are gonna go around the base of the bottom tube. It's gonna be with epoxy, and I also have some tiny little metal pins that I'm just gonna drill in and epoxy in just for some additional mechanical connection, okay? All right, next up is our nose cone, and this here is gonna go right on top. This is a 3-inch diameter rocket, and this is a 3-to-1 conical nose cone, okay? And this is its little coupler, and that goes down on it like that. It's gonna epoxy in, and then when it's time, this goes right in there as well, okay? And it'll slide all the way down. Next up here, I just have metal pins for the fins like I talked about. These are miscellaneous nuts, bolts, washers for the AV bay. And here are rail buttons with screws and washers, okay? Had to go and measure with a 1010 rail to make sure I would have clearance. One of the rail buttons are gonna have to go inside one of the fins, and we'll be good. These are charge bays, okay, or charge wells. All right, that are gonna go on one side of the E-bay because I'm really just gonna use that for the dual deployment that pops up top, okay? I'm gonna rely on motor ejection for the bottom part, okay? Here I have some shear pins and rivets. The rivets are gonna secure the AV bay to the body. That way it doesn't separate during dual deployment, and the little shear pins are gonna go inside here and here to make sure that the nose cone stays locked on tight until the dual deployment happens and it shears those pins and releases, okay? Here's a couple of sheets of Nomex to protect our 2 parachutes. Here's the other Kevlar shock cord. I have 2 15-foot long Kevlar shock cords, 1550 strength, and the nice ones from Lock come with an already braided loop on either side. I've done my own knots, but I do like these when I can splurge for it. This I may not use because the Kevlar anyway is already rather robust when it comes to black powder discharge, but this is just an extra protector that I have left over. I might find a reason to use that. Now here's our 2 parachutes, and there were some equations. I'll post the equation down here that I had to work out in order to calculate based on weight and weight with motor what is the maximum size parachute that I really should be using for the main parachute that'll come out during the dual section of the dual deployment, and the drogue chute, the smaller one. And so these are the measurements I ended up needing. I need a 48-inch nut, and I went with the apogee parachute, they're quite nice. And then here went with the 12-inch parachute for the drogue. Now, here we have that motor mount that I was talking about, or motor retainer. Here are forged eye bolts. They came with nuts, 1 nut. I got an additional nut and additional washers here to be able to secure it to our bulkheads when needed, okay? But there are 3 of these. These are probably more strength than I need, but good for up to 20-pound rockets, and flirting with 9, so needed something stronger than the lower level ones. Got some additional 22 gauge wire for our dual deploy setup. Same thing here, that is a wire connector, quick connect. These are what's known as terminal blocks, and these help us just with clean and quick connections for the AV bay to the actual charge wells. These are our quick links. And you can see here, 1/4 inch large, rather robust again, rated for the right kind of size rocket we're doing here. And this guy, this is just a little extra something I splurged on. This is an Aeropack 54 to 38 millimeter adapter, meaning if I ever want to shoot an I-500T or even do my own I-600 with this rocket, then I can insert this up into the motor mount and use a 38 millimeter motor instead of just 54. I also have these nickel-plated swivels, and these, what they do is they attach and allow the parachute to spin freely without tangling up your wire, which, when you're doing dual deployment, is, well, a nice bonus if you can swing it. So, what do we have next? Next, there's a huge list of things that I need to do to make this rocket happen. We're gonna start with actually securing these down. There's going to be a method in which I do it, though. I'm not going to do this one until later, until maybe even after I put it inside the rocket, but I'll walk you through that in the next video. Thanks, everybody.